Hey everybody, welcome to another support video. This one is kind of the corrections for a practice solving systems of equations sheet that I gave out to my class. If you happen in my class, you're just using this to correct. If you're not in my class, then you're maybe going to be finding this helpful in terms of how to solve systems of equations. It's just demonstrating a couple examples in different ways. So if you're someone who needs to learn how to solve systems of equations, this might be a good resource for you. Anyways, all right, let's get into it. So in this case, the first system here, we have three ways to solve a system. You can look for the intersection point, which is the solution to the system, by graphing it and seeing where the lines intersect. That's one way. Another way is to use substitution. So you solve for one variable in one of the equations and then plug it into the other equation, right? So that you can solve for the place of intersection in terms of one of the variables, and then you can plug in to find the other. And then the other way that you can do it is through elimination. So you have the system of equations. So you have these two linear functions that happen to be in standard form or something like that, where you can easily combine them. You combine them in such a way to eliminate either the x term or the y term so that you can solve for the other. And then once you solve for one of them, you plug it back into either of the originals and find out the place of intersection that way. So there's three different ways to do it. What I'm going to do for each of these examples is I'm going to do all three ways, and then you can decide which way works best for you. Sometimes the graph is really easy and it works out nicely where you know exactly where the lines intersect. Sometimes it doesn't work out nicely and you have to use something else like substitution or elimination to find it. So the first example, we're going to try the graphing method first. And it says system number one, y equals negative 2x plus 5, and then 6x minus y equals negative 1. Now, if we're graphing, I think it's easiest to do it from slope-intercept form. So what I recommend is we change both these into y equals mx plus b. So this one's already in y equals mx plus b, the first line. So I'm going to put that right here, y equals negative 2x plus 5. It's already set up for us. The other line is 6x minus y equals negative 1. So we're going to solve for y and put that into slope-intercept form. So here we have 6x minus 1y is equal to negative 1. You want to get y by itself. So I think the easiest way to do this is just to add y to both sides and then add 1 to both sides. And when you're done with that, you're going to get y on one side is equal to 6x plus 1. So that's it. Pretty simple, right? Remember, when you're just doing this quickly, if you have terms like this, you can just move a term to the other side of the equation by changing its sign. So the negative y becomes a positive y when you move it across the equals line, and the negative 1 becomes a positive 1 when you move it across the equals line. That's like the shortcut. Either way, you have y equals 6x plus 1 as our second line there. So that's y equals 6x plus 1. All right, cool. And now what we're going to do is we're going to just graph these based off of slope-intercept form. So the first thing I'm going to do is graph line number 1. The y-intercept is 5, and the slope is negative 2. So with a y-intercept of 5, you go to y value of 5 and put a dot. And then the slope is negative 2, which means down 2 into the right 1. So as x increases by 1, y decreases by 2. So to the right 1, down 2, put a dot. To the right 1, down 2, put a dot. To the right 1, down 2, put a dot. To the right 1, down 2, put a dot. That's what a slope of negative 2 looks like. You can also go up the stairs, right? So you go up 2 into the left 1, up 2 into the left 1, up 2 into the left 1. So there you go. You've got plenty of points to make your line, and then just lay your line down on top of that as neatly and carefully as you can with a ruler. And make sure you extend beyond the points, and you put arrows on either end because it goes forever in both directions. Okay, so there you go. There's line number 1. All right, great. We did line number 1. Now let's do line number 2. So line number 2 is 6x plus 1. So it has a y-intercept of 1 and a slope of 6. So that means up 6 into the right 1. So from there, we're going to go up 1, 2, 3, 4, 5, 6 into the right 1. There's your staircase of movement. We can't really do it again. Watch 1, 2, 3, 4, 5. 6 would be somewhere up here, the right 1, but it's hard to know exactly where. So now we're going to go down to get our third point. You always need 3 points for any line you graph because you want to make sure it's a good, accurate line. 2 points make a line, but that could be any line. Doesn't mean it's the right line. The third point being on the line tells you it's the right line. So you always want at least 3 points when you graph a line. So anyways, we're going to go down 6 because the slope is positive 6. It's going to be down 6 into the left 1. So down 6, 1, 2, 3, 4, 5, 6 to the left 1. And now we've got our 3 dots, so we can make a nice clean line here. And we're going to just take our ruler, make it blue, and let's connect our dots. Now remember, even at the best of times, a graph like this is just an approximation of the lines because you are going to make errors in terms of where you place the lines or how you go through the center of the dots and so on and so forth. It's very rare that you're going to get perfect representation here with this graphing model. It's going to be a slight approximation. So if it happens to cross it exactly in order pair, in other words, as you move the slope from one line or the other, you end up exactly at the same dot on another slope, another line, then you can use it and trust it. In this case, we can't really trust it because we don't have a solid dot that matches up, right? These dots aren't going to all be the same anywhere. So there's no place that we've identified that's the exact location of the solution of the system. Now, we do know kind of where it's located, right? It's kind of located there. So there are some things we can say about the solution to the system here. We can say that the intersection between these two lines, or the solution of the system, is somewhere between certain x values and certain y values. So it's right here, right? So it's definitely between 0 and 1 on the x-axis, and definitely between 4 and 5 on the y-axis. Looks like it could be exactly 4. Looks like it could be a half. But if I were to think of it as a half and half 4, that would be an assumption. And you don't want to make an assumption about where this is. You want to know exactly where it is. So we can't really solve this perfectly with the graph. We can make a guess at it. We have an idea of where the intersection occurs, somewhere between 0 and 1 on x, somewhere between 4 and 5 on y, but we don't know exactly what that location is. So just to fill in some points here, by the way, you can algebraically plug in values. I'm going to plug in -1, 0, 1, and then 2. -1 times -2 is 2. 2 plus 5 is 7. 0 times -2 is 0. 0 plus 5 is 5. 1 times -2 is -2. -2 plus 5 is 3. 2 times -2 is -4. -4 plus 5 is +1. And we'll plug in some points over here. Let's do the same thing. -1, -0, let's do 1 and 2. -1 times 6 is -6, plus 1 is -5. That's funny. I wrote -0. Not hilarious. There's no -0. Anyways, so this one's going to be 0 times 6 is 0. 0 plus 1 is 1. 1 times 6 is 6. 6 plus 1 is 7. And then 2 times 6 is 12. 12 plus 1 is 13. So ultimately, we have our ordered pairs here. You could probably check to make sure that you did the line correctly. We checked it algebraically just now by plugging it in. We can make sure it matches the graph. Let's just make sure it matches the graph. 0, 5, yep, that's the dot right there. Oh, -1, 7, -1 up, 1, 2, 3, 4, 5, 6, 7. That's the spot right there. So I feel like this is the correct line. And then on the blue, we could just check to make sure we graph the line correctly. -1, -5, -1, -1, 2, 3, 4, 5. That's a verified point. 0, 1, that's a verified point. 1, 7 over 1 up, 1, 2, 3, 4, 5, 6, 7. That's a verified point as well. So you can just verify the points, just to make sure that your graph is correct. Anyways, once you've done all that, the next thing you're going to do is solve it with substitution. So we know the graphs look pretty good. We kind of have a sense of where the answer is. We want to know exactly where the answer is. So y equals -2x plus 5 is one of our lines, and our other line is y equals 6x plus 1. Both of these are in y equals mx plus b, which is the easiest way to do substitution. It's just to plug right into y equals mx plus b, and I'll show you why. If you're using substitution, basically what you're going to do is you're going to take the y value from one equation, and you're going to replace the y value in the other equation with that. So you're going to literally substitute in y for y. And what you're really doing here is you're saying, I want to know where the y's are equal, right? Where's this left y equal to the right y? So if I set the y's equal, right, basically that's what I'm doing. I'm saying y equals y. So therefore, -2x plus 5 must be equal to 6x plus 1. So that's what you get, and we're going to solve that equation. So -2x plus 5 is equal to 6x plus 1. And where the y's are equal, you're going to have this x value, right? So this is the x value of where the y's are equal, of the intersection. So let's do it. Little equation here, no problem. Let's do in purple. So we want to get all the x's to one side, all the numbers to the other. I would add 2x to both sides and -1 to both sides. You're going to get net positive 4 is equal to 8x, then divide by 8 both sides, and you're going to get x is equal to 1/2. Now, we already assumed that was the case, but we weren't sure. So all we've done right there is we've proven that, yes, this is 1/2. All right, so the x value of our intersection is 1/2, just like we thought. That makes sense with our graph. We think the y value is going to be 4, but it could be slightly bigger or slightly less, right? It could be like 3 and 9/10, or it could be like 4 and 1/11 or something. We have no idea, right? But we want to find out that value. It's going to be around 4. So now to find the y value, what you're going to do is you're going to take this x value, we're going to plug it into either equation to solve for y. Now what I like to do in general is I like to take the x value, plug it into one of these to solve, and plug it into the other one to check. Okay, so let's do a solve and a check. So 1/2 times -2. So let's do it. Y is equal to -2 times 1/2, the x value, plus 5. 1/2 of -2 is going to be -1. -1 plus 5 is in fact 4. So based off of this solution that we came up with, it looks like we think that this is going to cross at negative 1/2 positive 4, so just like we thought. So in this case, our assumption would have been correct. But now we're going to check it on the other point just to make sure it's correct. So now we're going to do a little check on this side. We're going to say, is it true that when y is 4 and x is 1/2, we get a true statement, right? Is this a solution? All right. So 4 is equal to 1/2 of 6, which is 3, plus 1. And yeah, 4 is equal to 4. That is true. So now we've proven that with substitution, we got the correct answer, and that's going to be 1/2 4. Okay. The next thing you're going to do is you're going to try to do this with elimination. Now, in order to do elimination method, you want both of the lines in standard form, okay? Now, we have one of the lines in standard form up here, right? 6x minus y equals -1. That's line number 2. So I'm going to write that in first. So line number 2 here is going to be 6x minus y is equal to -1. Did I copy that correctly? 6x minus y is equal to -1. Yes? And the other line is y equals -2x plus 5. So for line number 1, we're going to start with y equals -2x plus 5. And what we're going to do from there is we're going to solve, rearrange it into standard form. So to get into standard form, all you got to do is just bring the x to the left so it's the same side as the y. So this is actually a really, really easy process. So literally all you have to do on this one is you're going to just add 2x to both sides, and you're done. Okay, so this is going to become 2x plus y is now equal to 5. So here we go, 2x plus y is now equal to 5. Now, when you're doing elimination, you're going to basically combine the two lines into one line, like basically looking at what they look like together, right? Because you want to find out where they intersect, where they're together. And ideally, when you do this, the way you can solve the equation is if one of the variables, either the x or the y, goes away when you combine it, then you can solve for the variable that you have left, and then plug it in to find the other variable when you're looking for the intersection point. So in this case, we got 2x plus y equals 5. We got 6x minus y equals -1. If you were to combine it exactly as it is, what you'll notice is that you already have a situation where when we add these two together, one of the variables goes away. So if we were to combine these, right, 2x plus y equals 5 plus 6x minus y equals -1, you're going to end up with 8x because 2x plus 6x is 8x. And y plus -y is going to be 0. So that's eliminated, right? That's been eliminated. And then 5 plus -1 is going to be 4. And what you're left with there is very simple. 8x is equal to 4. And then if you solve for x, you're going to get that very same 1/2 that we already have. Great. So now we know that the x value is 1/2. This is the method we used just now is called elimination, right? So we used elimination to solve for the intersection point. We found that x is equal to 1/2. And then what you do to get the rest of the answer is you know that the x value is 1/2. To find the y value, you just take that 1/2 and plug it into either of your equations. We already know the answer is going to be 4, but just to have fun and finish it off, we're going to take this x value and plug it into, let's say, the top equation here. So you'd say 2 times whatever x is plus y must be equal to 5. And we're going to solve using this one here. Let's just write solve. And then if I didn't already check it, I would check with the other one. But since we already checked it, we don't need to check with the other one. But here we go, 2 times 1/2 is 1, and so 1 plus y is equal to 5. You want to -1 to both sides, and obviously y is equal to 4. Hence, we get our intersection point, right? So we already know this is the right one. We've seen it twice before that this is about right. We already have the solution in check here, so I don't need to check this one a second time. But if why not? Why not? What's the harm? So if I wanted to check it using elimination, I would just plug into the other equation, right? So then I would check over here, and it would be 6 times the value of x, which is 1/2, minus the value of y, which is 4, is equal to -1, and then 3 minus 4 is -1. Hence, we have a correct answer. Awesome. Okay, so this is the process that you're going to go through when you're doing these problems, and that's how you get the answers. All right, let's do the next one. So for this one, you are going to do the same exact thing. So you notice you got one line in slope-intercept form, one line in standard form. The line that's in slope-intercept form is already great. Let's just write that in here. Y equals 2/3 x plus 2. And let's graph it. So y-intercept of 2 and a slope of 2/3. That means up 2 to the right 3, up 2 to the right 3, and then down 2 and the left 3, down 2 and the left 3. 1, 2, and then 1, 2, 3. All right, cool. And so there's your dots. Let me do the little line through those. So we're all on the same page. And extend it out through the dots as best you can. Put arrows in either end. All right, and filling in the table here, I would pick values that are going to cancel out that fraction. So I'm going to do -3, 0, 3, and 6. -3 times -2/3 is going to be -2. -2 plus 2 is 0. Does it cross the x-axis at -3, 0? Yes, it does. So that's a verified point. Then you've got 0 plus 2, which is going to be 2. Does it cross the y-axis at 2? Yes, that's a verified point. And then 3 times 2/3 is 2. 2 plus 2 is 4. And then 6 times 2/3, 3 goes into 6 twice. 2 times 2 is 4. 4 plus 2 is 6. So there's your ordered pairs. All right, I feel pretty good about those. And then for the other line, we're going to do line number 2 here. All you're going to do is you're going to solve for y and put it in slope-intercept form. So 7x plus 3y is equal to -9. You're going to then minus 7x to both sides to get the y by itself. 3y is equal to -7x minus 9. And you're going to divide by 3 all terms. And you're going to get slope-intercept form, which is y equals -7/3 times x minus 3. So write that in, y equals -7/3 x minus 3. Okay. When we graph this one, we're going to start at -3 on the y-axis. That's the y-intercept. So we can see that. And it's a slope of -7/3, which means down 7 and to the right 3, or up 7 to the left 3. Let's go up first. Up 1, 2, 3, 4, 5, 6, 7, and to the left 1, 2, 3. 1, 2, 3. There we go. And the other way is down 1, 2, 3, 4, 5, 6, 7, and to the right 3. Down 1, 2, 3. Let's move this down so we have more room. Down 1, 2, 3, 4, 5, 6, 7, and to the right 3. All right. That's the slope of -7/3, right? And it crosses the y-axis at -3. So now that I've got all that, let's see if we can draw a nice line through this using our tools, our trusty tools here. So we can see that they do intersect, right? There's one solution to the system where these lines intersect, but we don't know exactly where. As you guys can see, it's not an exact dot that was duplicated on both lines. So that means that we don't know exactly where that is. We have a range of values that we can trust for that, but we don't know exactly the answer. So the graphing solution method only gets us close to the answer. We know it's somewhere between -1 and -2 on the x-axis, and somewhere between 1 and 2, or like maybe at the worst 0 and 2 on the y-axis. So we don't know the answer yet. Okay, cool. Let's finish graphing the blue line here just with the table. So I want to make sure I know how to fill in the table. I'm doing multiple by -7/3, so let's use multiples of 3. So I would do -3, 0, 3, and 6. Negative times negative is positive. 3 goes into 3 1 times. 1 times 7 is 7. 7 minus 3 is going to be 4. And then 0 times -7/3 is 0, minus 3 is -3. And then 3 times -7/3, the 3's cancel out. You get -7. -7 minus 3 is -10. And then 6 times -7/3 is going to be a negative. 3 goes into 6 twice. 2 times -7 is -14. -14 minus 3 is -17. And that makes sense, basically, because as the x increases by 3, the y is decreasing by 7, right? -7/3. So now that we've got our graph and our table, everything's looking pretty good. The next thing, we can verify these points right away. -4, 3, 4, -3 up, 1, 2, 3, 4, that's verified. 0, -3, that's verified. And 3, -10 over the right 3 and then down 10. And yeah, you can see that's also verified right there. Boom, okay. Now let's plot our little lines here. So we got our slope-intercept form for way number 2. We're going to do substitution. So we know that y is equal to 2/3 x plus 2. And the other one is y is equal to -7/3 x minus 3. You're going to take the value of y from one and substitute into the other. So we're going to say that 2/3 x plus 2 is going to replace y in the other equation. This is called substitution. Basically, what you're doing is you're setting the y values equal. So you're basically saying, all right, y equals y, and this will give you the x location of where the y's are the same. So the one y value, 2 thirds x plus 2, is equal to the other y value, which is negative 7/3 x minus 3. So we're going to solve this system. 2 thirds x plus 2 is equal to negative 7/3 x minus 3. We want to get rid of our fractions, so we're going to multiply the whole thing by 3, all terms. 3 goes into 3 once. 1 times 2x is 2x. 3 times 2 is 6. And then on the other side, negative times a positive is negative. 3 goes into 3 once. 1 times 7 is 7. And then negative 3 is just negative 3. Okay. Oh, my bad. Negative 3 times 3, my bad. 3 times negative 3 is negative 9. I was like, what am I doing there for a second? I'm tired. All right, so anyways, do we multiply every term by 3? Let's see. 3 times 2 thirds x is 2x. 3 times 2 is 6. 3 times negative 7 thirds is negative 7. And 3 times negative 3 is negative 9. Yeah, now I feel pretty good about it. All right, let's get all the x's to one side, all the numbers to the other. I do see that I forgot to write the x in. Silly me. Boop, there we go. And so let's write the answer here. We're going to add 7x to both sides. We're going to minus 6 to both sides. You're going to get 9x is now equal to negative 15. Divide by 9 both sides. And x will be equal to negative 15 over 9, which is the same as divide top and bottom by 3, negative 5 thirds. Okay? So x is negative 5 thirds, or ultimately negative 1 2 thirds. Ask yourself if that looks like it's reasonable. So is this x value right there of the intersection negative 1 2 thirds? Does it look like 2 thirds of the way between negative 1 and negative 2? Yeah, it does. It's reasonable. So let's write that in, negative 1 2 thirds. That's our x answer. Now we got to find our y, right? So we're going to take this x value. We're going to plug it into the left equation, and then we're going to check it with the right equation, because it's got to be a solution that works on both lines. And so when we do that, we can plug it in and check. So we're going to solve with y equals 2 thirds x, and the x is negative 5 thirds, basically, plus 2. I think it's easier to plug it in that form. So what you get there is y equals positive times a negative is negative, and then 2 times 5 is 10, and 3 times 3 is 9, so this is negative 10 ninths. And then how many ninths is 2? That's going to be the same as plus 1 and 9 ninths. And that's actually not enough ninths to take away the 10 ninths. So what we should do is we should just rewrite that as, let's double the ninths, so 18 ninths, right? So 18 ninths is equivalent to 2. So this would be negative 10 ninths plus 18 ninths. And then 18 minus 10 is going to be 8. So this is just going to be positive 8 ninths. Now, what we have here is a situation where, just like I told you, you don't want to make the assumption that that's at 1. Right? We didn't know what it was. It was somewhere close to 1, but we weren't 100% sure what it was. So obviously it's 8 ninths. It's very close to 1, but not exactly 1. So you have to be precise with this work. That is the precise answer. Now we're going to check the precise answer in our other equation. So we're going to say that, all right, if everything works out the way it's supposed to, then 8 ninths should be equal to negative 7 thirds times our x value, which is negative 5 thirds, minus 3. Let's see if this is a true statement. Negative times negative is a positive. 7 times 5 is 35, so that's 35 ninths, because 3 times 3 is 9. And then negative 3 is the same as negative 27 ninths. And is 35 minus 27 equal to 8? And the answer is yes. So therefore, we have corrected this, and it works. So we do know the correct answer here should be negative 1 2 thirds, comma 8 ninths. Right, now we solved it with the substitution method. Now we want to double check it by solving with the elimination method. So our elimination method is going to say we have standard form for line number 2. So let me just grab that line number 2, standard form there. It's going to be 7x plus 3y equals negative 9. So I'm going to write in here. So number 2 is going to be 7x plus 3y equals negative 9. So 7x plus 3y is equal to negative 9. And then our other line was going to be y equals 2 thirds x plus 2. So we're going to write that out and then rearrange it, okay? So for line number 1, we're going to say it starts off being y equals 2 thirds x plus 2. And we want to get this into standard form. So the easiest way to do that is to just multiply the whole thing by 3 to get rid of the fraction, because you want integers as your coefficients. So it's going to be 3y is equal to 2x, because 3 goes into 3 one time. 1 times 2x is 2x, plus not 2 in this case, but 2 times 3, which is 6. All right, and then once you have that value, the next thing you're going to do is you're going to move the x's to the same size as the y, but you want the x to be a positive. So what I'm going to do is I'm going to minus 3y to both sides, and I'm going to minus 6 to both sides. And so ultimately what you end up with is 2x minus 3y is equal to negative 6. Okay, so 2x minus 2y equals negative 6. Here we go. 2x minus 3y is equal to negative 6. If you were to combine these right now, does anything get eliminated that you want, right? Does the y term go away or the x term go away? In this case, it works out pretty easily for us. As you guys can see, when you combine these right now, the y terms will in fact cancel out, right? So 2x minus 3y equals negative 6 plus 7x plus 3y equals negative 9 will leave you with 9x. I'll write it over here on the left-hand side just so I can do it. Therefore, 9x, negative 3y plus 3y is going to be 0, and then negative 6 plus negative 9 is going to be negative 15. So you guys can see here, I can write it here, that is worth this, right? And solve it, or we can just solve it over here. Either way, we're going to get the same answer. It's going to be negative 15 ninths, which is the same as negative 5 thirds, which is the same as negative 1 2 thirds, which is exactly what we got before. See, boom, boom. So this method is called elimination, right? Where you have standard form and you add the two together to try to eliminate either the x term or the y term. And so there's your negative 1 2 thirds, and then you just plug into one and then check with the other. So I'm going to do a little check here. We'll do a solve with this top line. We'll do a check with the bottom line, okay? So solve and check. All right, check over here. Okay, so first let's solve it. So we know that the ordered pair is the x value of negative 1 2 thirds, or negative 5 thirds. So I mean 2 times negative 5 thirds minus 3y is equal to negative 6. So that's going to be negative 10 thirds minus 3y is equal to negative 6. And that's going to be add 10 thirds to both sides. You're going to get negative 3y is equal to, and this would be the same as 3 goes into 10 3 times, so 3 1/3, right? So it'd be 3 1/3, so negative 6 plus 3 1/3. Who's going to win? The negative by how much? Well, take away the 3, get 3, and then take away the 1/3. So you'd be looking at basically 2 2 thirds, right? Because if you add 2 2 thirds plus 3 1/3, you're going to end up with 6. All right, cool. So that will work out pretty nicely. And then the next thing you're going to do is you're going to divide by 3 both sides, by negative 3, I should say, both sides. And so you get your answer, right? So in this case, our answer is going to be negative 2 2 thirds divided by negative 3. That's going to be a positive value. And this is 2 times 3 is 6 plus 2 is 8. This is going to be 8 thirds divided by, well, let's just do this way. 8 thirds, right? We know it's positive because negative divided by negative is positive. So it'll be 8 thirds times the reciprocal of 3, which is 1/3. So that's going to end up being positive 8 ninths. And there's our answer. Boom. And we already know that's the correct answer, right? But now we have it in another form, found by a different method. And so we know the x value is going to be negative 1 2 thirds of the intersection, and the y value of the intersection is going to be 8 ninths. And that's the solution to the system. And you can always check it by plugging into the other equation, make sure it works. And in this case, we know it will, so I don't want to waste your time. But we could plug it in. I'll plug it in. So 7 times the x value of negative 5 thirds plus 3 times the y value of 8 ninths should give us a value of negative 9. And this should be a true statement, so this is our check. In other words, proving that this point is on both lines. And so 7 times negative 5 is negative 35. So it's negative 35 thirds. 3 times 8 is 24, so plus 24 ninths should be equal to negative 9. And if you multiply top and bottom here by 3, you're going to get ninths. So that would be 90 plus 15, so 105. So it would be negative 105 ninths plus 24 ninths should be equal to negative 9. And if you take away 4 from 105, you get 101. And take away 20, you get to 81. So this is going to be the same as negative 81 over 9, which is obviously negative 9, so that works fine. So that's how you do the problems. This is the work that I'm looking to see from you guys, and this is how you could solve each of these problems in 3 different ways. So there we go. Hopefully that was helpful to you.